Hi everyone. In today's video, we are going to discuss this example. Actually, this differential equation is of reducible to exact differential equation. So before starting this example, we will revise few concepts of exact differential equation and then we will move further. See, when you have differential equation in this form, m dx plus n dy is equal to 0. Where m and n both are functions of x and y, like this. Okay, so actually it is looking different. We need to convert the given differential equation in this format first, right? If you have differential equation in this format and partial derivative of m with respect to y, it's same as partial derivative of n with respect to x. If these two partial derivatives are equal, then we say the given differential equation is exact. If it is exact, it is quite simple to find its solution since we have a direct formula for that. Getting? But let us check first the given differential equation is exact or not. Okay. So see, the given differential equation should be in this format. So let us convert it in this format. So what we have, see, what will I do? I will solve this bracket. Okay. So let us take the product x e raised to x dx minus this x e raised to x into dy plus e raised to x dx plus y e raised to y dy is equal to 0. So now what will I do? I will collect the terms of dx. You can easily see there are two terms of dx, this one and this one. Okay, so I will take dx common. So if you take the dx common, you will have x e raised to x and here e raised to x dx outside, and we have a two terms of dy, right? So let us take dy common. So if you take dy common, okay, so I'm writing this term first, y e raised to y. It has a minus sign, minus x e raised to x dy, and this is equal to 0. It means that I express the given differential equation in this format. Multiple of dx is our m and multiple of dy is our n. So let me note down our m and n. Here m is x e raised to x plus e raised to x, n y e raised to y minus x e raised to x, right? Now I will find the partial derivatives and I will check whether those are same or not. So consider partial derivative of m with respect to y. So let us find partial derivative of m with respect to y. This is my m. There are two terms, so I will take the separate derivatives. Derivative of x e raised to x plus derivative of e raised to x. So you can easily see we are differentiating with respect to y. So x and all functions of x are constant. So this is a constant since there is no any y and x is there, and we are differentiating with respect to y. Derivative of constant is 0. Same thing happens here. We are differentiating with respect to y, but we have a function of x. So that's why x is a constant and its derivative will be 0. So del by m by del by y 0. Okay, so let us find now del by n by del by x. So let me do that thing here. Just a minute. Now del by n by del by x. Okay, what is my n? This is my n. So I will take the separate derivatives. Since there are two terms which are separated by minus sign, so when you have two terms, we can take separate derivatives. Derivative of what? Y e raised to y minus derivative of x e raised to x. See, there is no any x. We are differentiating with respect to x. Y and all functions of y are constant. Derivative of constant is 0. Getting? Minus. See, now we have to find derivative of x e raised to x. See, both are functions of x and there is a multiplication. So I should use this formula. Derivative of u into v. U into derivative of v plus v into derivative of u. So when you have product of two functions and when we have to find derivative, we have to use this u into v formula. I will do the same. X derivative of e raised to x plus e raised to x derivative of x. So let me write here minus x. Derivative of e raised to x is e raised to x plus e raised to x. Derivative of x is 1. Getting? Yes. So let me remove this part and let us find its value properly, right? So you can multiply. So minus x e raised to x minus 1 into this one minus, and minus plus minus e raised to x into 1 e raised to x, right? So yes, we got dabba n by dabba x. So dabba n by dabba y is 0. Dabba n by dabba x is this one, minus x e raised to x minus e raised to x. So both are clearly different. Okay, it means the given differential equation is non-exact. Let me clearly mention, therefore, dabba m by dabba y minus dabba n by dabba x, is not equal to dabba n by dabba x, implies given differential equation is non-exact. See, if the given differential equation is exact, it is quite simple to find its solution. But if it is non-exact, no need to worry. We have a method to convert this non-exact differential equation into exact differential equation. We find integrating factor, and with the help of it, we will convert this non-exact to exact differential equation. So now the question is how to find integrating factor, right? So actually there are 4 different rules of finding integrating factor. So let me tell you one by one, and after that we will see which rule is applicable. See, the first rule is dabba m by dabba y minus dabba n by dabba x upon n is equal to f of x. See, when you find the difference between these two partial derivatives, divide by n, and if you get just function of x only, it means there should not be any y. In that case, integrating factor will be e raised to integration f of x dx. The second rule is dabba n by dabba x minus dabba m by dabba y upon m. Simply we interchange them, right? And it should be the function of y only. In that case, integrating factor will be integration e raised to integration f of y dy. Here we should not have function of x or any term of x. We should have y, terms of y and constants only. In that case, we go for rule number 2. The third rule is applicable when you have the differential equation in this format. Okay, this format, what I'm writing. Okay, so f1 of xy, that means xy should appear in pair everywhere. Sin xy, e raised to xy, everywhere you should have xy. In that case only we can think about rule number 3. And rule number 4 is applicable if the given differential equation is homogeneous. Homogeneous, that means power of each term is same. Okay, so I always suggest you to go for rule number 3 and 4 first, because it is quite easy to check. Getting? Otherwise, in case of rule number 1 and 2, we need to solve, we need to give some time for it. Then we will realize, yes, that rule is applicable or not. Getting? So always go for rule number 3 and 4 first. So let us check with rule number 4. So can we say this differential equation is homogeneous? No. Since e raised to x is there, e raised to y is there, when you have just polynomial functions, then we can talk about homogeneous. But we have exponential function, so we cannot go for rule number 4. It is not homogeneous. So let us think about rule number 3. So we should have xy, but see, in a power of e, we have just x only. We are not having xy. We want xy everywhere, no? So rule number third is also not applicable. See, now we have just two options. Either we should go for rule number 1 or rule number 2. So what will I do? I will try for rule number 2 first. Okay. And if it doesn't work, then I will go for rule number 1. Okay. So let us see what will happen. I also don't know what is going to happen. So let us see. Dabba n by what we had written there. So consider dabba n by dabba x minus delta m by delta y upon m. Okay, so let us find its value. Delta m by delta x, where is it? Here. Minus x e raised to x minus e raised to x minus delta m by delta y. It is 0, simply 0. Divided by m. Where is m? Yes. X e raised to x plus e raised to x. Okay. So what we are expecting, we should have just function of y only. We don't want x anything. Okay. So let us try to simplify. What can we do here? Can I take minus sign common from numerator? Definitely we can do. So I'm taking minus sign common. So you will have x e raised to x plus e raised to x upon. In denominator we have x e raised to x plus e raised to x. Did you notice one thing? We have got the same bracket at numerator denominator. So we can definitely cancel. Right. So what we are having here, we have simply minus 1. Okay. Actually, we were expecting there should not be any x. Yes, and we got it. Right. We got it. There is no any x. So you can declare it as a function of y. Okay. I agree. There is no any y. Okay. There is no any y, but there is a constant function of y. That means you should have either y or a constant. Getting? There should not be any x. And there is no any x, so you can declare this as f of y. So that means the rule number 2 is 100% applicable here. Okay, so that rule says the integrating factor is e raised to integration f of y dy. So let us simplify. So e raised to integration, what is my f of y? Minus 1 dy. So that minus 1 constant will come outside dy. So e raised to minus y, integration of dy is y. Yes, I got finally integrating factor. So what will I do with this integrating factor? Let me call it as equation number 1. So what will I do? I will multiply equation 1 by this integrating factor. Then that non-exact differential equation will be converted into exact differential equation, right? Multiplying 1 by e raised to minus y we get. Okay, but see, now there is no more space to write. Just make a screenshot of it, then I will move further. So I multiplied given differential equation by this integrating factor e raised to minus y. Okay, so that's why after multiplying we have got this differential equation, and this is 100% exact differential equation. If you want, you can cross check by checking the condition delta m by delta y is equal to delta n by delta x. We are getting a exact differential equation. So let me clearly mention, this is an exact differential equation. See, now what will I do? So this is our new m. So let me note down our new m. Multiple of dx is our m. Getting? So e raised to minus y, x e raised to x plus e raised to x, right? So this is m. N, let me write n. N is this one. So e raised to minus y. N means multiple of dy, right? Y e raised to y minus x e raised to x. See, what I feel, it will be better if you simplify this bracket. Okay, I hope some terms will get cancelled to each other. So let us do e raised to minus y, y e raised to y minus this e raised to minus y, x e raised to x. So this is equal to y. You can easily see we are having e raised to minus y, e raised to y. It means what is actually happening, let me tell you, e raised to minus y into e raised to y. It means 1 upon e raised to y into e raised to y. Power is negative, so that's why you can shift to the denominator. Terms will get cancelled and you will have 1 only, right? So those terms will get cancelled. We will have in y just minus e raised to minus y, x e raised to x. Now it is looking more better, right? So yes, so let us find its solution now. The solution is quite simple. Solution of exact differential equation is integration of m dx, treating y constant, plus integration terms in n free from x dy is equal to c. That will be the solution. That means solution of exact differential equation contains some simply addition of these two integrals. It is difficult to solve two integrations simultaneously. I will solve one by one and then we will find the answer. So let us think about the first integral. Consider integration m treating y constant, right? With respect to x, integration. What is my m? This e raised to minus y, x e raised to x plus e raised to x dx. So y is constant. So e raised to minus y is also constant. You can take it outside. Outside. See, tell me, can I take e raised to x common here? Definitely. No, e raised to x we can take common, and we will have simply x plus 1 dx. So now the question is how to solve this integration. Since you can see there is a product of two functions of x, right? So you cannot make them separate easily. Yeah, let us see how to solve such integrals. Okay, so let me tell you the formula first. The formula is integration uv is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on, right? See that dash stands for derivative, and this suffix 1 2 3 4 stands for integration. It means the first integration of v, second integration of v, triple integration of v, fourth integration of v, and so on. So while choosing u and v, you should follow this formula LIATE. L means what? Logarithmic functions. I means inverse trigonometric. A means algebraic or polynomial. T means trigonometric, and E means exponential. This sequence we should follow while choosing our M and N, U and V, right? So e raised to x, it's exponential function. X plus 1, it's polynomial, that means algebraic function. You can see in this sequence, A comes before E. So that's why I need to shift this bracket first. So let me write. So this is equal to e raised to minus y x plus 1, okay, e raised to x dx. Now it is looking better. So a algebraic function comes before that exponential function. We have followed the sequence LIATE. It means this is our u and this is our v. So let us follow this formula. E raised to minus y. So u as it is. What is my u? X plus 1. X plus 1. That's it. v1, that means integration of v. What is the integration of e raised to x? Same, e raised to x. After that we have a minus sign. Getting? We are having alternate plus minus sign. So I need to write minus. U dash, its derivative. What will be its derivative? Derivative of x is 1, derivative of 1 is 0. So we are having 1. v2, that means double integration of v. One more integration of e raised to x. E raised to x plus, we are having alternate plus minus sign, u double dash. One more derivative, that means initially we wrote u, derivative 1, one more derivative, derivative of 1 is 0. See, when we get 0, we terminate the process, we stop there. We never go up to infinity, okay? It is not possible, we cannot go up to infinity. So when you get derivative 0, we terminate the process and we declare that will be the answer. Yes, so 0 we are getting, so I should terminate the process, right? That's it, finish. So e raised to minus y. Did you notice one thing? E raised to x we have got. So let us take e raised to x common, e raised to x. We are having bracket here, x plus 1 minus we have 1. So plus 1 minus 1 will get cancelled. And this is e raised to minus y into e raised to x, x. So it is better to write x e raised to, base is same, you can add power. So x minus y. So finally we got the value of first integral. So let us think about the second integral. Now integration, the second integral is terms in n free from x with respect to y. How many terms are there in n? Where is my n? This is my n. How many terms are there? 2 terms are there. We want a term free from x. There should not be any x. Why? There is no any x, so I should write. But in second term there is x, so you cannot take the second term. dy. Integration of y is y square by 2. I hope you know this formula. I simply followed this formula. Integration of x raised to n is x raised to n plus 1 upon n plus 1. There is no any power of y. That means the power is 1. We increase it by 1. So 1 plus 1, 2, same number in denominator. So I got it. Let me remove this part. So the solution, it's time to declare the solution. Solution means simply addition of this two integrals. So x e raised to x minus y plus y square by 2 is equal to c. So this is a required answer. Okay, so let me highlight it. This is required solution. So in this way we solve this problem. Now I'm going to give you one problem for practice. You have to try that problem on your board. In case of you have any difficulty, you can watch my next video in which I'm going to cover its solution. And if you want to cross check your answer, then also you will get it in my next video. Just make a screenshot of it, then I will give you the practice problem.